A function is continuous at every point in its domain if it is defined for every point in its domain and equal to the limit for each point. That is, if the limit as x approaches a of the function is equals to f of a. So, for all a coming from the domain, assuming the domain of the function is real number. Example to explain this definition is given function f of x to be 1 over x for all x coming from real number except the point 0. So this function is continuous for all x coming from R except 0. But if this function 1 over x, this function is not continuous for all x coming from real number. The point of discontinuity is when x is equals to 0. So theorem 1. Every polynomial function are continuous function. That is, the limit as x approaches c of the function f of x will be equals to f of c. So whenever the function is of the form polynomial, is always a continuous function. Theorem 2, if f and g are what? Continuous function, then the composite function is also a continuous function. So that is, f composition g is a continuous function. If f is a continuous function, then f inverse is also a continuous function. To show that the following functions are continuous on their natural domain, it means, where is this function defined? G of x is a square root of x squared minus 2x minus 5. Square root function is always defined for all x coming from what? 0 to positive infinity. So x squared minus 2x minus 5 is a polynomial function. So every polynomial function is what? Is a continuous function by theorem 1. The composition of square root with x squared minus 2x is also a what? A continuous function. So the composition of the two functions is a what? Is a continuous function. F of x equals to absolute value of x minus 2 over x squared minus 2. Here, absolute value is a continuous function because the graph is always, so it's a continuous function. Denominator must not be 0, that is, x squared minus 2 must not be 0. To check if this function is continuous function, this is what is called piecewise function. The first thing to check is to check the continuity property. The first continuity property says f of c. In this case, c is what? C is 1. So what is f of 1? F of 1 is when the function is exactly equality. This is the function 5. Here is less than, here is bigger than. So this is the equality part. F of 1 is 5. Limit as x approaches 1 of the function. What is this limit approaches 1 of this function? Whenever the left hand limit is equals to the right hand limit of the function, then you say the function has limit. The value is going to be the limit of the function. So what is going to be the left hand limit of the f of x? The left hand limit is when it is less than, x is less than, to positive infinity minus 1 to negative infinity. This is when 1 plus approaching it this side, but 1 negative approaching it by the left. So this is when it is less than. This is x squared plus 3x plus 2. This is going to be 1 squared plus 3 plus 2. The function is going to be 6. So the limit The left hand limit is 6. What is the right hand limit? The right hand limit of the function is to check when it is bigger than, this is the function, 2x plus 1. This is the same thing as 2 to 1 plus 1, 3. So the left hand limit of the function is equals to 6. 6 is not equals to 3, which is equals to the limit as x approaches 1 to the positive of the function. So the left hand limit is not equals to the right hand limit. Limit does not exist. Since the limit does not exist, the second property of continuity, the second failed. So this function is not a continuous function at point x equals to 1.